I am a trained doctor in the medical specialty of orthopedics, and the title of this project is The Effect of Thread Length in Cancellous Bone Fixation Under Shear Loading and Biomechanical Study. The presentation will be structured as follows. First, some general information regarding cancellous bone screws will be provided. Then the motive and the purpose of the study will be outlined. Then the experimental protocol and the results will be presented. And finally, the discussion and the conclusions will be presented. A bone screw acts as a simple machine that is designed with specific morphological features in order to achieve maximum efficiency when inserted into bone. The stability of internal fixation depends on the mechanical coupling between the bone and the screw threads. Partially threaded 6.5 solid core cancellous screws are commonly used as lag screws for the fixation of intra-articular fractures of the metaphysis of long bones. The lag screw fixation technique refers to a surgical technique used to achieve interfragmentary compression and absolute stability between the two bone fragments. The thread length corresponds to the length of thread engagement in bone, and it has been found to correlate with the holding power of screws in cases of porous materials like cancellous bone. However, only 3 studies were found to investigate the effect of thread length in fixation under shear loading. In these studies, the mechanical behavior of constructs fixed with either fully or partially threaded screws was assessed. The constructs were then subjected to shear loading, and various mechanical properties were calculated and compared between the two groups. In all these 3 studies, it was indicated that the constructs fixed with the fully threaded screws exhibited a better mechanical behavior than those fixed with the partially threaded screws. Due to the fact that this is a relatively unexplored area of investigation, we decided to examine the effect of thread length on fixation under shear loading. The experimental laboratory data were then analyzed and correlated with the clinical implications of the findings. Soap-on blocks composed of solid rigid polyurethane foam were used as a substitute for cancellous bone. In addition, 6.5 solid core partially threaded cancellous bone screws with a length of 75 millimeters were used for the fixation process. All of the screws were made of titanium alloy. As a first step, 18 pieces of soap-on blocks, each having a length of 90 millimeters and a cross-sectional area of 40 by 40 millimeters, were precisely cut from the original block. A 3.2 drill bit was then used to create the pilot hole. The pilot hole was drilled to the screw's length. After drilling, each soap-on block was precisely cut into 2 blocks, block 1 with a length of 30 millimeters and block 2 with a length of 60 millimeters. 2 types of 6.5 partially threaded cancellous screws with varying thread lengths were used of 16 millimeter and 32 millimeters, as we can see in picture A. The constructs fixed with the 16 millimeter threaded screws, the short threaded screws, were labeled as group A, while the constructs fixed with the 32 millimeter threaded screws, the long threaded screws, were labeled as group B. The screws were inserted from block 1, the small one, so as to ensure that the threaded part for both screw types effectively surpassed the fracture line. By this technique, axial compression was produced between the 2 blocks. The screws were inserted by using the standard hexagonal screwdriver shaft attached to a torque limiting handle. A torque limit of 2 Newton meters was implemented for the insertion of the short threaded screws in group A, while a torque limit of 2.5 Newton meters was implemented for the insertion of the long threaded screws in group B. In order to prevent the head of the screws, the head of the screw from subsiding inside the show bone during insertion and during the loading of the all the experiments were carried out by using an MTS inside loading frame under a displacement control mode per second. The load was applied at an outer surface of block 1, while block 2 was rigidly clamped with a metallic frame. The data were collected from 9 constructs of group A and 9 constructs of group B, and the force displacement curves were obtained for each construct. The stiffness, the proportionality limit, the conventional yield force, and the yield displacement were calculated for each test piece. After a series of preliminary experiments, it was decided that the loading of the constructs should be terminated when the total displacement, as measured by the loading frame, should exceed the 1.5 millimeters, since in all the experiments, the deviation from linearity occurred well before that limit. The stiffness was defined as the slope of the best fitted linear equation, which in this case we can see that it is equal to 461.6 newtons per millimeters. The proportionality limit was defined as the force corresponding to the terminal point of linearity. In order to define the yield force, a straight line parallel to the stiffness by an offset of 0.015, as it has been adopted by the clinical literature, was drawn and is depicted here as a blue line. And the intersection point between this blue line and the load displacement curve defines the yield force, and the corresponding yield displacement can be detected in the horizontal axis. Some of the data were excluded from the analysis due to being identified as statistical outliers. This table displays the experimental data obtained from the loaded displacement curves of its tested construct, while the loaded displacement curves from group A samples and group B samples are presented in the graphs below. The statistical data for the mechanical properties of the two groups are presented in this table, while the following graph presents comparative bar charts of the mean values of the properties under study. SPSS was used for the statistical analysis of the results, and it was indicated that the constructs fixed with the long threaded screws exhibited statistically significantly greater yield force, proportionality limit, and stiffness compared to those fixed with the short threaded screws, while no statistical significant difference was detected between the two groups for the yield displacement. A post-experiment and investigation of the show bone blocks after the completion of the tests and the removal of the screws indicated that the failure of the show bones occurred through compression, which resulted in the crash of the pilot hole due to extended bearing failure, while the screws remained intact without undergoing any obvious plastic deformation. Certain fracture types are more inherently subjected to shear stress due to the structural architecture of the skeleton, such as femoral neck fractures or tibial plateau fractures. Therefore, it is essential to investigate the effect of shear loading in the various fixation methods. The thread length has been found to correlate with the holding power of cancellous bone screws. In 1996, Chapman proposed the use of a formula that is used in machine screws in order to predict the pull-out force of the cancellous screws. According to this formula, the pull-out force is proportional to the length of the thread engagement. However, as mentioned earlier, the effect of thread length in fixation under shear loading has not been adequately investigated. The findings of our study are in line with the previous research because we also found that the constructs fixed with the long threaded screws had a better mechanical response than those fixed with the short threaded screws. In this study, the constructs fixed with the long threaded screws required a higher insertion torque limit for adequate tightening than the constructs fixed with the short threaded screws. And as a result, different interfragmentary compression forces may have been induced between the two groups. Higher compressive forces are likely to have occurred in the constructs fixed with the long threaded screws due to a higher insertion torque limit. The main conclusion drawn from this study is that the constructs fixed with the long threaded screws exhibited a statistically significantly greater stiffness, proportionality limit, and yield load than those fixed with the short threaded screws. As a result, it can be concluded that the thread length is an essential feature of screw design that may affect not only the holding power of screws, as it has been already indicated in the existing literature, but also the resistance of a fixation under shear loading. Furthermore, this study may serve as a basis for further examination in this relatively unexplored field. In addition, more research can be conducted on the mechanical response of cannulated screws that are more commonly used. And finally, the experimental data of this study may be used for the validation and calibration of numerical models for the simulation of the specific fixation problem. Thank you.